A very good evening. As you know, I have started a revision lecture series for Bpsc, AE, advertisement number 29 2025. So we have taken the subject Geotechnical engineering, in which lecture 1 revision already uploaded on my channel. You can go and see. This is the second lecture, revision lecture 2, which is continue from the revision 1. Let us start. In this lecture, we have considered there is so many relations on which lots of questions have asked in the past. Numerical based question, that is very simple question, only based on this relationship. So let us start. The first is, let me change the color of the pen. First lesson is SC is equal to WG. So here S is the degree of saturation of the in soil, E is the void ratio of the soil, W is the water content in the soil, and G is the specific gravity of the soil. So this relation SE is equal to WG. As you know, the degree of saturation is nothing but the volume of water divided by volume of void. So this is the volume of water divided by volume of void. So this ratio is called the degree of saturation. And void ratio, we know the volume of void divided by volume of solids. This is the ratio of volume of void to the volume of solid. Means solid में कितना void है, that is the void ratio. Third one is the water content. There is so many methods to determine water content, we discuss in later phase. And G is the specific gravity. As you know, the specific gravity is nothing but the weight density of solid divided by weight density of any standard fluid, that is water, at 4 degrees centigrade. So you can also write this density, weight density is weight per unit volume. So volume of solid divided by volume of weight of solid divided by volume of solid, that is weight density of the soil. So this is the specific gravity. Specific gravity is unitless quantity. Unitless quantity. Specific gravity is unitless quantity. These all are the ratio, so it is unitless quantity. Now there is a relation among void ratio and porosity. So void ratio is equal to n divided by 1 minus n. So void ratio is designated by E. This is void ratio and this is porosity. So relationship is void ratio is equal to n divided by 1 minus n, and n is the porosity. So there is also relationship between porosity and void ratio, that is n is equal to E upon 1 plus E. There is so many questions based on this relationship. And this porosity is nothing but the ratio of volume of void to the total volume of the solids. Volume of void to the total volume. Third one is mass specific gravity, designated as GM. GM is equal to gamma D divided by gamma W, that is dry density divided by dry density of the water. So gamma D divided by gamma W. This is also, you can write that Ws divided by Vs is the gamma D and multiplied by gamma W. So specific gravity, that is G, is always greater than Gm. Specific gravity of soil is always greater than the mass specific gravity of the soil. Mass density is also equal to Gs divided by 1 plus E. Means specific gravity of solid divided by 1 plus void ratio. This is also a relationship between mass specific gravity and specific gravity of the soil. And also mass specific gravity is equal to Gs 1 minus n. So when you write 1 by 1 plus E, 1 by 1 plus E, it becomes 1 minus n. So you can write this Gm is equal to Gs 1 minus n. Next one is bulk unit weight. There is relationship between bulk unit weight. So bulk unit weight designated as gamma B, and the relationship is gamma B is equal to G plus SE divided by 1 plus E into gamma W. Here all the terms are understood. Means S is the degree of saturation, E is the void ratio, gamma W is the weight density of water, like that. So similarly, this is for bulk unit weight and this is for saturated unit weight, that is gamma sat is equal to G plus E divided by 1 plus E into gamma W. This is for dry unit weight, gamma D is equal to G gamma W divided by 1 plus E into gamma W. Next one is submerged unit weight. So submerged unit weight, you know, when you subtract saturated unit weight to unit weight of water, you will get the submerged unit weight. So submerged unit weight is restricted at dash, gamma dash. So this is G minus 1 divided by 1 plus E into gamma W. Here is one notes in that which density is greater, means there is a ascending order of this density, ascending descending order. So gamma saturated is always greater than the gamma bulk. Gamma bulk is greater than gamma dry density, and gamma dry density is greater than gamma submerged density. Means a saturated unit weight is always higher than the bulk, dry and submerged unit weight. So it is nearly approx 20 to 22 km per meter cube, and dry density is approx 18 to 20 km per meter cube. So if you see, the submerged unit weight is 10 km per meter cube. So it is nothing but gamma submerged is equal to half of the gamma sat. This is 10 and this is 20. So it is almost half of the saturated unit weight. So you can say the gamma submerged is half of the saturated unit weight. Next relation is many times the question asked on volume base, means volume and void ratio. Suppose two things are there in which one this mass of volume is excavated, and here is the deposition of the volume of this mass, means soil, volume of this soil. So sometimes the void ratio and volume of one thing are given. You have to find another where the void ratio is only given, so you can find the how much volume is required. So based on that, this is the relationship. So V1 divided by 1 plus E is equal to V2 divided by 1 plus E. Here V1 and V2 is the volume of the solids or soils. Next relationship is percentage of air void, that is eta A, designated as eta A. This is nothing but the ratio of volume of air to the volume of solids. Volume of air to the volume of solid is the air void ratio. If you talk about air content, this is nothing but volume of air divided by volume of void. Volume of air divided by volume of void. And there is important relationship between air content, AC air content, and degree of saturation. So air content is equal to 1 minus degree of saturation. This is the degree of saturation. Next relationship is also is the same using this air void. When you want to find the wet density of dry soil, and you have given the air void ratio, at that time there is a relationship, that is gamma D is equal to 1 minus Na, that is air void, into gamma W divided by W plus 1 upon G. G is the specific gravity. So if you have a specific gravity and air void, you can and also the water content, you can find the dry density of the soil. And it is also written like this. You just rearrangement of this term, and you can write like this: 1 minus Na G gamma W 1 plus Wg. Next term is density index. Density index. Density index, it is also called as relative density and degree of packing. Density index is also called as degree of packing. The relationship for this degree of packing is equal to E max minus E divided by E max minus E min, means void ratio at minimum wet density, that is E max, void ratio at natural, natural void ratio of the soil, and ratio of E max minus E min, that is again the void ratio at minimum wet density and void ratio at maximum wet density. So when wet density is minimum, you will get the maximum void ratio. When wet density is maximum, you will get the minimum void ratio, and from this you can get the dry density of the soil or relative density. If you want to the percentage of dry density, you just multiply this factor by 100. This factor multiplied by 100, you will get the value in percentage. What is the use of this dry density? It is used to estimate the angle of internal friction. It is used to estimate the angle of internal friction. And this density index you can find by a test called as PCPT, that is portable cone penetration test. Portable cone penetration test. This is used for to estimate the density index. There is a range, some tabular values here, and this is sometimes not, it is many times asked in the competition exam. That is, if you get the relative density between 0 to 15, then the soil is called as very loose soil, means the state of the soil is not well compacted, that is very loose soil. And if it is 15 to 35, it is loose soil. Again, if it is 35 to 65, it is medium dense soil. If it is 65 to 85, it is dense soil, and for greater than 85, this is very dense soil. So you can classify the types of soil based on the relative density. Here is the some ranges of this void ratio, porosity, air content, saturation, water content. Water content is always greater than 0. As you know, what is water content? I have discussed here. Water content is the volume of water divided by volume of void. Void ratio is the volume of void divided by volume of solid. So based on that, you can see here water content is always greater than equal to 0, and void ratio is always greater than 0, greater than 1 also, right? But porosity is never greater than 1. It is ranges between 0 to 1. Air content is also between 0 to 1. Air content is also between 0 to 1, and degree of saturation is also between 0 to 1. So only water content is greater than equal to 0, or void ratio is greater than 0. Now there is some limits, that is liquid limit, plastic limit, semi-solid, solid. If you see in the graph, okay, so like this. So suppose here is the liquid limit. So liquid limit is the border between a liquid state and plastic state. Liquid state, if it is liquid state, it is plastic state. So the border between liquid state is denoted by liquid limit, and it is obtained by a formula, that is liquid limit is equal to Wn multiplied by n by 25 raised to c. C is the constant which value is given in the question. So based on that, you can find the liquid limit, and 25 is the number of blows. If you remember the things, there is like that. So a curve is like that, logarithmic curve, and based on that curve, means a Casagrande apparatus is there. There is experimental setup. If you discuss all the things, then a video will be going to lengthy. So just you remember these things. Wn, natural water content, n divided by 25, where n is the number of blows and c is the index, which value is given in the question. And plastic limit is the border between a liquid limit and solid limit. Liquid limit and solid limit. So this is the plastic limit. And semi-solid is the border between plastic limit and solid limit, and above that there is a solid. Next is the shrinkage limit. Shrinkage limit is designated as Ws and it is related to mass specific gravity, that is 1 by gm minus 1 by g, that is specific gravity multiplied by 100. From here you can find out the shrinkage limit, and at shrinkage limit degree of saturation is equal to 1. So you can also find Se is equal to Wg, S is equal to 1, E is equal to Wg. So from here this relationship also you can find sometime the shrinkage limit. Shrinkage limit after that there is some index based on this limit. There is some index, that is plasticity index, liquidity index, consistency index, flow index. So what is plasticity index? It is nothing but liquid limit minus plastic limit. So the difference between liquid limit and plastic limit is the plasticity index, and liquidity index is nothing but the ratio of this natural water content minus plastic limit divided by the plasticity index. This is called as liquidity index. You have to remember that in liquidity index there is no liquid limit, right? And in consistency index there is a liquid limit. So consistency index is designated as IC, liquidity index is designated as IL. So IC is equal to, again, the ratio of liquid limit minus natural water content divided by the plasticity index. Next one is the flow index. Flow index you can find by again there is a practical approach, that is W1 minus W1 and W2 is the water content at N1 and N2. N1 N2 is the number of blow. So W1 minus W2 divided by log base 10 N2 upon N1 is called as flow index, and it is universally proportional to the shear strength. If you increase the shear strength, the flow index will decrease. If you decrease the shear strength, flow index will increase. And last one is the toughness index. This is nothing but the ratio of plasticity index to the flow index. Plasticity index to the flow index. And plasticity index, you know, WL minus WP, and flow index is the, here is the flow index. So toughness index IT is equal to IP upon IF. There is some range of this plasticity index. If the plasticity index is 0, then it is non-plastic. If it is less than 7, this is low plastic, and if between 7 to 17, it is medium plastic, or if it is greater than 17, this is high plastic. So this is the range of plasticity index. Next one is sensitivity. Sensitivity is defined as the undisturbed soil strength divided by the remolded soil strength, means it is the ratio of Q undisturbed to Q remolded. This is the Q is the undisturbed soil strength. The range of this sensitivity, if it is between 2 and 4, called as normal sensitivity. If between 4 to 8, then it is called as sensitive. A soil is called as sensitive soil if the sensitivity is between 4 to 8, and if it is 8 to 16, then it is called extra sensitive, and if it is greater than 16, this is called quick sensitive, like quick. Next one is the activity. Activity is many times so many times we have seen in exam that the numerical question asked on this activity. This is hardly take 1 minute to solve this question. So this is activity is the ratio of plasticity index to the percentage fraction of clay finer than 2 micron. Percentage fraction of clay finer than 2 micron. Range of this activity is, if it is less than 0.75, then it is called as inactive. So for normal activity, the activity number between 0.75 to 1.25, and if it is greater than 1.25, then it is called as active. So inactive, normal and active. Less than 0.75 is inactive, 0.75 to 1.25 normal, and this is active. Now there is so many methods to determine water content, that is oven dried method, pycnometer method, radiation method, sand bath method, sand bath method, calcium carbide method, torsion method, and alcohol method. Calcium carbide method is the quick method of determination of this this water content, and oven dried method is the most accurate method. This is asked many times in the exam. Pycnometer method, there is a formula for pycnometer method. This is determined experimentally, that is W1 minus W2. You can see like this, circular. W1 minus W2, W3 minus W4 into G minus 1 by G minus 1 into 100. Here W1, W2, W3 and W4 is the weight of different condition when soil plus container, when only soil, when soil container plus water. So these are the 4 weights. Next one is the recovery ratio. What is recovery ratio? Recovery length of the sample divided by penetration length of the sample. It is designated as LR. So many times ask the range of this recovery. If recovery ratio is less than 1, then soil has compressed, and if it is greater than 1, then soil is swelled, and if it is equal to 1, the good recovery. So for good recovery, the recovery ratio should be equal to 1. Next is the coefficient of uniformity. Coefficient of uniformity is nothing but D60 by D10. D60 by D10 is designated by Cu. Coefficient of curvature is designated by Cc, and Cc is equal to D30 square divided by D60 into D10, where D60 is the size, means percentage passing, 60% of size passes through the sieve, like D is the means it is talking about the size of the soil. Okay, where D10 is the effective size, D30 again the 30%, like that. Range of this coefficient of uniformity and coefficient of curvature, you can see in detail the soil classification system, but here is the simple range which is asked in the exam for revision. That is, if you find that coefficient of uniformity is greater than 6, then it is called as sand, and for gravel it is greater than 4, and if the curvature coefficient of curvature is between 1 to 3, then it's a sand or gravel, means well graded sand, right, or well graded gravel if it is between 1 to 3. Similarly, for sand it is greater than 6, and for gravel it is greater than 4 for well graded, right. This is for well graded sand or gravel. Okay. Next relationship is critical hydraulic gradient, that is IC. This is G minus 1 divided by 1 plus E. So many questions asked on this critical hydraulic gradient. Or when you find this IC, you can, if the factor of safety is given, you can find the permissible gradient, and if permissible gradient is given, then you can find the factor of safety, right. So factor of safety is IC divided by IE. Next is coefficient of permeability. There is 2 types of coefficient of permeability. One is horizontal permeability and vertical permeability. So horizontal permeability, you can find, suppose there is different layer K1, then there is thickness of that is H1, next layer K2, permeability is K2, thickness is H2, like that. So if it is horizontally aligned, then you can find the equivalent horizontal permeability is like that, K1 H1 plus K2 H2 plus K3 H3 divided by H1 plus H2 plus H3, and it is vertically, then H1 plus H2 plus H3 divided by H1 by K1 plus H2 by K2 plus H3 by K3. Next one is effective coefficient of permeability, K equivalent. It is nothing but the root over Kx Ky, or Kx into Ky raised to 1 by 2. This is the equivalent coefficient of permeability. So a numerical question is also asked on this relationship. And last one is the stresses. So suppose you have to find this, here is the stress. So how much depth of this place. Okay, if the soil is filled, if this is the soil and you find the stress at this point, okay, soil, stress in the soil. So total stress is what? Whatever be the density of this soil, that multiplied by this depth z, that is called the total stress at this point. But there is also water in the soil, so you need to find the pore pressure of this soil. So pore pressure is gamma w into z. So effective stress is equal to total stress minus pore water pressure. So you can find the effective stress, because pore water pressure is expulsion of water, like from the, it is squeeze out from the surface. Okay, so it is a negative, pore water pressure is negative. That's why effective water is always the difference between total water minus pore water pressure. So you can find this, and pore water pressure is density of water into the depth of this gamma w into z. So this is all for today's lecture. I think this is very useful to you. Thank you. Bye bye.